Good day, folks. In this tutorial, I will be discussing the calculation of the second moment of area, quote unquote, uh, moment of inertia of 2D geometries, which which is meant to be either a flat surface or a flat face of a 3D object. Okay, and I'm going to be doing it in the 3D Experiences Catia software. Now, first of all, uh, it happens that this calculation is done in the icon, which is saying measure item, not in this icon, which says measure inertial data. However, that's exactly what it was in Catia V5. If you wanted to do this in Catia V5, you would have to do it in this icon, which is measure inertia, but not in 3D Experiences Catia, which is done in the measure item. Okay. Now, incidentally, in the Catia program, unfortunately, finding the second moment of area was also referred to as moment of inertia, which is a misnomer. But anyway, that is taken care of in this 3D Experiences version. Uh, so the CATIA version of this tutorial, CATIA V5 version of this tutorial, has already been uploaded, and you can find it in this link. In case you're not interested in 3D Experiences CATIA, you can, and you're interested in CATIA V5, then this is the link that you have to go to. The first thing that we're going to do is to make sure that my units for inertia and inertia product, okay, is set as I want it to. In this particular example that I'm going to show you, I will be using millimeter for dimension, and therefore the inertia property, inertia or moment of inertia, is going to be millimeter to the 4. And in future video where I will do a mass moment of inertia, I will be using this kilogram millimeter square, but not in this tutorial. So you go to the preferences on the units, and this thing pops up, and then you search for inertia. These two will pop up. Make sure these are selected as you want. Okay. And for this particular tutorial, as I mentioned, all I need is this inertia line, okay, which is millimeter to the 4. Now, as an example, I will be doing this problem for you. So we have a triangle. The coordinate system is set up here, and if you go to any strength of material book, you will find that this can be found somewhere there. Actually, I shouldn't say any, but some. The second moment of area with respect to x-axis is right here. Second moment of area with respect to y-axis is right there, and the product of moments, or product of inertia, let me put it this way, which is misnomer, is given by that. Now, the example that I'm going to be doing is going to be this length is 1,000 millimeter, this height is 500 millimeter, and this C distance here is 300, which means from that vertex to the y-axis is 700. You go through these calculation and you come up with these as the principal direction, principal inertial values. Okay, so these are principal moment of second moment of area, and when you do this thing in the 3D experience under the measure item, you'll get this dialog box, and notice that the centroid is given correctly, and this is a moment of inertia matrix or tensor, and notice that I have on the diagonal I have exactly the same numbers, and on the off diagonal this is 0, and the calculation also give you very close to 0. Notice that this goes from 10 to the 9 down to 10 to the minus 8. So for all practical purposes, these are 0, which matches this. As a second example, I will be using a rectangle, and the information for the moment of inertia with this, or moment of area with respect to x and y axis, are given there. Obviously, in this case, because of symmetry, ixy will be 0 right there. I'll be using a rectangle of dimension 1000 millimeter by 500 millimeter, and I should be getting these numbers. Incidentally, this second example, I will do it as a padded object, and I select the top face of it so that it's not a surface. For the first one, I'll do a surface. Okay. All right, let's go ahead and do that. So let's go to, there's the interface. Let's make sure that units are set correctly. So I'll go to preferences, and under units, this dialog box shows up. If you type in here inertia, notice that these two pop up. Already it's correct. It's millimeter to the 4, and I don't use this thing for the present tutorial, but it's kilogram millimeter square. Okay, that's good. Let me close that. All right. So I will be making this rectangle for you exactly in the same planes that they mentioned. So X this way, Y up there. So we go here on the XY plane. There's the XY plane. I will sketch. Okay. So notice that X is going down and Y is going to the right here. So which is fine. And of course, if you don't want to see it like that, you just click on the normal view. This flips it one more time. Now X goes to the right, Y goes up, which makes it easier for me to see what happens. So you just click on the normal view, it changes that. So let's go ahead and make our rectangle. We'll fix the dimensions in a minute. Okay, first of all, this should be this. Let me dimension these things. This should be 1000 millimeter. It says, should I have right now proportionally make everything bigger? Yes, makes it easier for us. So right there. So this is 1000 millimeter. Now let's dimension the distance from the top to this line. Dimension from that vertex to this line to be 500. All right. And then dimension from that point to this axis 700. Okay, good. Excellent. So exit. I'm going to put a surface on this, a flat surface. And this is why I need it. As soon as I say surface, I have to do it in something like maybe generative shape design or other cousins of this generative shape design, which appear in 3D Experience. But that's okay. I'm already in generative shape design, and there is a fill icon on the click on the surface tab, and there is a fill somewhere here, right? Fill. You select this sketch, and it's going to put a surface on it. There we are. So what you see here, if you look at the view from the, for example, view from the, so you get it from the top, from the top. There we are. So this thing is that shape. Okay. So that's very easy. It's all done pretty much. So you select the tools. Notice that I have the setup here. I selected the tools tab and check for inertia, check for measure item. Let's go back here. So how do we do? We are in tools tab. Let's go all the way to the right. Find the measure right here. See a measure, and this one is measure inertial data, which is not where we're going to go in this tutorial. So you just go and measure item. See that? And you select this surface, and these things pop up, and look what we got here. These are the coordinates of the centroid, which is matching what we have here, 566, 166, and then what you see down below is the inertia matrix, basically. So really, the more appropriate way of labeling calling these things is a second moment of area. 3.223 10 to the 9, 3.223 10 to the 9, and 1.12 10 to the 10. 1.12 10 to the 10, and these are the principal direction. Incidentally, if you click on the results, there's very little stuff that you can actually display. You can display area, perimeter, center of gravity, and second moment of area. There is absolutely no reference to second moment of area in the Catia V5 version. They still call it moment of inertia, okay, but it has nothing to do with inertia. Anyway, that takes care of this tutorial. Oh, oops, wait a minute, I forgot to do the last example. This example. Okay, so let's go ahead and close this. By the way, if you want to export these to a different text file, you can do that, but I'm not going to do this. Uh, let me go there and do one more thing here, measure. Let's try it one more time. On the results, let's see now, let me see now, under export. If you say create geometry here, you create geometry, you click on it, and notice that it actually selects the centroid right there. Okay, see that? Selected the centroid, but that's really not critical. Okay, go. Let's go and do the second problem. So what I'm going to do is let me look at look at this thing from a different angle. Let's go to isometric, right there. So I'm going to make a padded object here. Okay, so on this same plane, I will sketch, or you can use any other plane, doesn't matter. A rectangle, and on purpose, I'm going to do it like that. On purpose, I'm going to do it like this. There's my rectangle. Let me put some dimensions here. This one is going to be 1,000 millimeter. And this fellow is going to be 500. That's what I had in the slide. Very good. Exit. And I want to pad this thing up now because it's going to be a solid object. I can do that here under volume, but I'd rather go to part design. There's the part design. And under essential, you find the pad here. And let me make it maybe something bigger so that I can see it. There. So this rectangle is 1,000 millimeter by 50 millimeter. So once again, I go to tools. I can do it here. Find the measure right there, measure item, and you select the top face. Notice that you're going to get the coordinates of the centroid, but you're going to get these numbers. One of them is 104 10 to the 10. The other is 4.1 10 to the 10, which is exactly what I have here. 1.04 10 to the 10 and 4.16 10 to the 10. So there we are. Now remember, these are the principal moments of area or principal inertias, and they are with respect to the axis, the coordinate system that goes through the center, centroid through the centroid of that top face. Okay, very good. That's the end. There will be other videos related to that measure inertia icon that you saw down here.